Let's look at this example of the seventh result of our limit theorem. Now, it is saying that if the limit of an is equal to a, where a is greater than or equal to 0, then the square root of the limit of an is equal to this. No. Then the limit of the square root of an is equal to the square root of the limit of an, which is equal to the square root of an. Alright? They had to put this part, a must be greater than or equal to 0, because you cannot find the square root of a negative number. Right? Can't work. Cannot find the square root of a negative number. But now let us look at what this is saying. An example. Suppose an is equal to, say, 25 minus, let's say, 1 over n. Alright? What's the limit of this? Even if you don't put 1 over n. If you put 15 over n, the same argument. Whatever number you put over n. The fact is, as n tends to infinity, then 15 over n or any other number over n would tend to 0. Right? So the limit would be 25. Now, the limit of the square root of this. So an is equal to 25 minus 15 over n. The square root of this function. Now, the first term would be 25 minus 15, which is 10, and you have the square root of 10. The second term will be 25 minus 15 over 2, which is 7.5, which is square root of 25 minus 7 would be 18 minus 0.5, 17.5, whatever it is, square root of that. Alright? Now, the 100th term would be 25 minus 15 over 100. The square root of that, we're finding the square root of everything here. The square root of 25 minus 15 over 100 would be the square root of 25 minus a small number. Right? But the argument here is, as we go on and on with the calculation, and n tends to infinity, 15 over n tends to 0. So what we have is the square root of 25, which is 5. So that's the limit of the square root. If the limit is 25, the square root of 25 is 5. Now, when we square root the whole function, right? So you see, what we did here was find the limit, and it is 25. Right? We find the limit of the square root of the function here. The square root of the limit of the function is this. Right? So that might be a bit confusing. Let me go with it again. The limit of the square root of the function is this. This part is the limit of the square root of the function. That's what we did here. We square root the function and find its limit. Here we found the limit first and then square root it. The limit is 25. And the square root of the limit is 5. This is what happened here. We found the limit first and then square root it. We found the limit as 25 and then square root it and got 5. That's what happened here. Here, remember, we square root the function and then found the limit of it. And we found the square root of 25, which is 5. The same 5 here. as we found here. You see the connection between the two, right? So what we do here actually show in this example that this works out. It is the square root of a. It is the square root of the limit. So without the many writings, for result number 7, if we find the square root of 25 minus 15 over n, as n tends to infinity, this part tends to 0, so we find the square root of 25, which is 5. Right? That's what happens here. Now what about this? If we find the limit, if an is equal to 25 minus 15 over n, and we find the limit as n tends to infinity, this part will tend to 0. So it will be 25. Now, if we square root it afterwards, the square root of 25 is 5. This part. And you see it's the same 5 that we have. Right? Now, what we therefore have is the square root of the limit. The square root of 25 is 5. So it works. It works for this example. And I can assure you it works for other examples. Alright? Whatever example is that you find, it will work. And I say that in the absence of the proof. As I say here, finding the limit using the definition is a long process. We won't bother to look at the mathematical proof. We just look at this example. So these are the results, 7 results from considering the limit theorem. If you add the functions and find the limit, it's the same as finding the limit of one plus finding the limit of the other. If you multiply the function and find the limit of that whole multiplication, it's the same thing as finding the limit of one multiplied by finding the limit of the other. You find the limit of one, you find the limit of the other and multiply them. Same thing as when you multiply them and then find the limit. If you divide them, divide the functions and then find the limit of that division, you get the same thing as finding the limit of one, then finding the limit of the other and then dividing them. If you have the modulus of the function and you find the limit of it, it's the same as finding the limit of the function and then finding the modulus. It's equal. They'll be equal. If you have a function that is positive, then the limit of that function will also be positive. Right? It will never become negative. If you have a function an greater than the function bn, then the limit of the function an will also be greater than the limit of the function bn. And if you find the square root of the function and find the limit, you get the same number. It will be equal to finding the limit of the function and then square root it. So these are the 7 results, the 7 results that you should remember. It's not really hard to forget. You don't even have to think about them once you know them while you're applying them to solving any problem.